JEE 2026, 4th April Shift 2, Physics, Question 48. Two identical bar magnets are placed with their centers 10 cm apart, with their axes perpendicular to each other. Point P is exactly at the midpoint between them. Two identical small bar magnets, each of dipole moment 3√5 joules per Tesla, are placed at a center-to-center separation of 10 cm, with their axes perpendicular to each other. The magnetic field at the midpoint P is alpha times 10 to the power minus 3 Tesla. Find alpha. Key concept: the magnetic field of a dipole. On the axial line at distance r, B axial equals mu naught over 4 pi times 2m over r cubed. On the equatorial line, B equatorial equals mu naught over 4 pi times m over r cubed. When two perpendicular fields combine, the net field is the vector sum using Pythagoras theorem. Step 1. Given values. M equals 3√5 joules per Tesla. Distance r equals 5 centimeters or 0.05 meters. R cubed equals 1.25 times 10 to the minus 4. Step 2. Point P is on the axial line of magnet 1. B1 equals 10 to the minus 7 times 2 times 3√5 divided by 1.25 times 10 to the minus 4. This gives 4.8√5 times 10 to the minus 3 Tesla. Step 3. Point P is on the equatorial line of magnet 2. B2 equals 10 to the minus 7 times 3√5 divided by 1.25 times 10 to the minus 4. This gives 2.4√5 times 10 to the minus 3 Tesla. Step 4. Since B1 and B2 are perpendicular, the net field is B net equals square root of B1 squared plus B2 squared. Substituting, we get square root of 4.8 squared times 5 plus 2.4 squared times 5 times 10 to the minus 3. This equals square root of 115.2 plus 28.8 times 10 to the minus 3, which is square root of 144 times 10 to the minus 3, giving 12 times 10 to the minus 3 Tesla. The value of alpha is 12. Exam tip: remember the factor of 2 difference between axial and equatorial fields. Axial field is twice the equatorial field at the same distance. When fields are perpendicular, use vector addition with Pythagoras theorem. Always convert centimeters to meters before substituting. Like and subscribe for more JEE main solutions at MAGPIEHUB.